So I really thank all of you for this opportunity and welcome. I know this has been going on for what? This is the third day now. So that's wonderful. And then thanks for introduction as well. So let me get on to what I thought I should try to see how what we do at NSF, especially what we do at Office of Advanced Cyber Infrastructure, the OAC, the new name now, right? How that fits into the multidisciplinary and interdisciplinary research and education. So I thought actually I do actually a little just quick survey as to what these terms really mean. So here is a slide on what I found. So multidisciplinary idea is that experts essentially stay in their own area within their own boundaries, but collaborate, right? Now, for example, Human Genome Project, web, and things like that. So that's where we use multidisciplinary, or supposed to use. Interdisciplinary is where multiple experts from different fields, they actually come to the boundary and they actually form new concepts and ideas. For example, bioinformatics and nanotechnology. Okay? And of course, you have another term, transdisciplinary, that is where the experts transcend the boundaries of disciplines and adopt holistic approaches. So when I talk today, actually we mean all of these. I will continue to use term multidisciplinary, but I think we definitely mean interdisciplinary as well as transdisciplinary. Okay. So let me just quickly introduce the Office of Advanced Cyber Infrastructure itself, the OAC, and we actually support, we foster user-inspired multidisciplinary research and development. We cater to all the disciplines. In fact, that's one reason why we are called Office now. We actually interface with all the directorates in NSF. Within OAC itself, there are 4 clusters: high-performance computing, data, software, and networking and security. And of course, the people that are needed for all these different activities, right? And I coordinate the people part, right? The learning and workforce development part. So I'll also put that in the context as we go through. Okay. And these slides are going to be available to you. So I'll send this to Dr. Panda, and then he will distribute. So why do we actually engage in this multidisciplinary and interdisciplinary research? And clearly there are exciting discoveries to be made. We feel that our expertise can be engaged in more interesting disciplinary research, also maybe deeper disciplinary research. And of course, we also probably feel that is a much broader impact that we can have. We can apply our expertise to something that's actually larger than what we can accomplish within our discipline. So there's a lot of excitement about what we do, and then clearly we also might think that there are funding opportunities, and all of these are actually true. So just for my own multidisciplinary work, I'll just quickly tell you what I have found. And I have found this actually to be quite exciting, and also I could go deeper into things within computer science. I'm a computer scientist, deeper into computer science discipline. I do algorithms and data structures in parallel processing settings. So we started looking at geospatial computation with some collaboration from faculty from Georgia Tech initially, and then of course we are collaborating now with Arizona State, University Minnesota, NCSA, and many other places, in fact. So those who actually are active in these areas, some who are disciplinary faculty, geoscientists and others, and some actually who are computer scientists also have this passion. And we have been extremely successful in actually conducting good science within computer science. So here is an example of a system that we developed for polygonal overlay. This in fact uses heterogeneous architecture using GPUs and such. And also we have looked at GPUs in the context of data structures. So there is a data structure called R-tree, where this allows, similar to B-tree, that allows representation of these polygonal objects, lines, points, and rectangles and things of that nature, which are potentially overlapping, allows them to be represented in a hierarchical fashion. It's one of the core data structures in the geoscience area, and we actually have successfully parallelized this with new algorithms, new ways of representing within GPU. So we got about 200-fold speed up for construction, 180-fold for querying and such. We have also now recently applied distributed plus GPU on this. And then there are some interesting algorithms, for example, special join. We have actually taken large scale data, almost 600,000 polygons, and we could process special join for real data sets within 8 seconds. So it's been quite fruitful. In fact, we have, I just recently, in fact, gave a keynote at IEEE Big Data Conference around this geospatial computation. So I think it actually has been fruitful in the sense of excitement and also producing some good results, right? Then what are the challenges though, right? Especially for the early career researchers who are trying to do multidisciplinary research. And so I'll actually cite one of the workshop series that NSF, in fact OSC, has been funding. These are called Cyber Bridges workshops. If you go to cyberbridges.org, all the annual reports are posted. Essentially, these are the PI meetings of career awardees from OSC and in related areas. And the finding is very interesting. Right? First, they have found that there are inherent structural, cultural, and disciplinary challenges encountered by these early career faculty who are trying to pursue interdisciplinary and multidisciplinary academic work. And the challenges involve areas such as seeking and securing research funding, earning tenure, and seeking multidisciplinary recognition. In fact, recognition within their own discipline and also across disciplines. Right? The second theme involves the interest of early career faculty in seeking acceptance and credit for their work that fully leverages computing technology available today for artifacts, for example, software that they produce, also data sets, critical data sets that can be easily referenced and cited in the broader academic community. So there are actually challenges. I mean, clearly, we shouldn't ignore that. But on the other hand, there are also great interest in terms of producing something more foundational and with much broader impact. So what are the opportunities and how does NSF actually support this? So I want to actually cite these NSF 10 big ideas. Most of you probably have seen this list. I wanted to put this out here. If you look at this list, there are research ideas and also process ideas, and many of these actually are multidisciplinary ideas. For example, harnessing the data, quantum leap, convergence. So clearly, if you look to the future, how NSF sees this, these are the ideas for future investment. So NSF does support what we are talking about right now. So let me then briefly talk about what OSC does and how we support this kind of activity. So we have 3 communities that I will talk about who we are concerned about. The first community I would say are those who are cyber scientists who develop new capabilities. They develop new simulations, new algorithms, new models, new architectures. I would call them CI contributors. They actually contribute directly to this CI ecosystem. Then also we have those who are area scientists, the domain scientists. These are the ones who actually are exploiting the new capabilities, new CI capabilities. I'll call them CI users. They use for their research. Right? The forgotten middle actually also I would highlight. These are the CI professionals, the other staff who actually help bridge the gap between these 2 communities that I talked about. And also they help deploy and support new capabilities. Right? So we are concerned about all these communities, and let me tell you about the programs which support these communities, both for research and now for training and education. Right? So we have RU Site program for student training. We also have for faculty research, we participate in the career program, that's NSF wide program for young faculty, and also we have CRA program. Right? And there's a lot of resource that's available. My slides will have some, and if you need, you can get in touch with me. And of course, we have this brand new program on training and workforce development, what is called Cyber Training Program. So let me start with the research programs. Our focus is on use-inspired or applied, multidisciplinary and advanced CI and computational and data-enabled science and engineering. Right? So you can see this is a very broad theme touching all disciplines around advanced CI. Right? So the faculty research, I talked about the career. This is the most prestigious award supporting junior faculty. In fact, for OSC, it's been a growing program. We doubled the number of submissions, then tripled last year, and in fact, this year is actually gone, it's quadrupled actually. So it's a very active, growing program. We have over 24 active awardees. For those who are early career, who might be thinking, or actually who might have colleagues, junior colleagues, let them know to look at the solicitation carefully. This round is just in, but for next year, it's now more open to tenure track faculty, non-tenure track faculty. Right? It has always been mostly for tenure track faculty. So the message is that's actually now more open to non-tenure track faculty. Okay? Also, collaborators are allowed on the budget. So look at that carefully. And this is essentially to support this growing trend of research scientists and non-tenure track folks who are actually also getting hired. They are engaged in research, and also they are engaged in broader impact of education, how the research really impacts the society. So look at that. CRI program, this is actually like a pre-career award program. It's always been open for faculty as well as research scientists and educators. This is for the first 3 years of their career as a faculty. Then of course the student training program, the RU site, is for research participation for actually undergraduates. You need to bring undergraduates typically during summer, mostly from outside your institution. And one of the key theme, of course, is to engage them in research. Another key theme is to also look at how we can broaden the participation from those institutions that do not have these opportunities. Okay. So let me then address how are we addressing these educational and training challenges, and that's where the cyber training program comes in. So let me talk about that. It's been quite successful. This is a new program. We just had a competition in January, and we'll have one more later in the fall. Based on NSCI initiative, I think some of you know that, as well as national academies and other reports. This in fact is complementing our research programs. We have led the formulation. There are 5 directorates which are participating, and the idea is to nurture and grow the nation's scientific research workforce. Right? So it's the research workforce that we are concerned about, all the 3 kinds of communities that I talked about. And the idea is to enable these by large-scale cyber infrastructure and related models in computational and data science, and the methods and the tools. And the idea also is to broaden participation by those with less CI adoption. Right? There are disciplines which do not have deep penetration of CI. There are lower tier institutions, and of course there are underrepresented groups. Okay? So the solicitation actually calls for developing innovative model, scalable model of training programs that lead to transformative changes in the state of research workforce development. Okay? And there are 3 tracks here. The awards are small size, 300K to 500K, up to 3 years in duration. 3 tracks, one for CI professionals, I talked about this community. Another track is for CI contributors, those who are actually directly contributing to CI ecosystem, and also a track for CI users, the computational and data science literacy, for those who are researchers, those who are future researchers, undergraduates, graduate students who actually are using. So essentially look at this like a pyramid. At the bottom you have large community of users who actually effectively use for research or potential research, and then you have those who are producing the CI ecosystem, and then of course you have the support staff. All 3 need training and cross training in many different ways. And then so look at this. I just said we had an excellent response. Next deadline is October. Be on the lookout for potential things around it. Okay. Also, if you have not signed up, go ahead and sign up for this ACI newsletter. I'll put a link and I will send it out. Go ahead and sign up for the newsletter. So in this context, I want to basically say that we are being very, very ambitious. I personally have been involved in trying to bring parallel and compute and distributed computing topics in CS curriculum, CS and CE curriculum, and that's what Dr. Panda talked about. The idea is to really, we thought about what every computer scientist really should know about parallel and distributed computing. What should be the core knowledge that everybody should know? Here's a link, and this effort has been going on for over 5 years now. This has informed the ACM 2013 CS curricula. Right? So it's going to have far-reaching impact. It's being revised right now, and so this is actually a community-wide effort. It's not something, and so we are looking for this kind of impact when we talk about cyber training program across different disciplines. Right? Okay, so let me go ahead and pause here.